Hello. This is my chemistry video on chapter 11, which is like balancing reactions and equations, stuff like that. And yeah, I'm gonna be doing the level 4. Yeah. And yeah, this is by me, Michael Matsuda. And yeah, let's get started on that. Alright, so the first question is identify the reaction type, predict the products, and balance BE2C plus H2O. So we can first, in order to find this out, we can make this into the complete ionic equation so we can get a better overview. And that would be simplifying it or separating all the ions. So then it'll be Be2 plus C4 negative. And then so for H2O, since this right here is an aqueous solution, right? That means it's dissolved in water. I mean, it is water, but when you're looking at this, you know it's gonna be since it's two compounds, it's gonna be double replacements. That means the two cations switch places. But in this case, since you look at H2O and then H2 by itself is a gas and O is a gas, it wouldn't really work like in a solution with water. So you separate it instead of H2 and O, you separate it so then it would be plus OH, which is hydroxide, which is soluble. It could be aqueous. And then you got plus just regular H, which can be in a solution. And so then you put that there. And then your products will be BeOH, because this one goes here, and then the other one will be CH4. And yeah, it's 4 because C is, if you look, it's -4 and this +1. So then to balance it, you need to have 4 here. And then this one will actually be 2. So then there'll be 2 here. Alright. And oh yeah, so this is balanced, and since we flipped it, it would be a the reaction type would be double replacement. Yes. And then these would be the products. And then we can balance the final equation, seeing that there's two H's here, and then 4 H's here, and then 2 oxygen, right? So then 2 plus 4 is 6. So then there'll be 6 hydrogen. Oh wait, let me shrink this for a second. Okay. So what we know is it Be2C plus H2O becomes BeH or OH, sorry, and that's 2 plus CH4. So we can balance this. So Be, we know that there's 2 right here, right? So that means there will have to be 2 here. 2 of these equation. Let me do a different color. So 2, and it'll be 2 of these equations. So that means this will be actually 4 hydrogen and 4 oxygen. And then that will be 4 hydrogen here. So these plus this will be 8. So there will be 8 hydrogen and 4 oxygen. And that means there will be twice as many hydrogen as oxygen. So you can get H2O. That'll go in 4. So then, yeah. So there'll be 4 H2O. And then just one of these. So it'll be, final would be 1 Be2C plus 4 H2O becomes 2 BeOH 2 plus, sorry, go right down here, CH4. Oh, that's one CH4, but yeah, you don't have to write the ones. And yeah, moving on to the next one. Alright, so the next part says, what experiment could you design to distinguish between a double replacement and a single replacement reaction? So we know that the main difference between a double replacement and a single replacement reaction is that in a single replacement reaction, you have uh, a single element and then plus a compound, let's say B, C, right? This is just variables, and then they become switched. So this it goes like that. So then it would be AC plus B by itself. But sometimes it won't work because it depends if this element right here is strong enough to push this element out of the way, I guess you could say, so that it could replace it. Some elements like lithium are more reactive and are since they're more reactive they can easily push out other ones which are less reactive, like let's say like silver, which is pretty low. And then in a double replacement reaction we have like two compounds, so AB plus CD, and then these two compounds switch cations. So then it would be AD plus BC. Oh wait, no, CB. Yeah. Uh, so yeah. So using this information, one of the easiest ways to tell the difference, um, I mean, it's kind of experiment because you're observing, I guess, is to see if there's a single element being used. If you know that there's only one element, a single element being used plus a compound, then you know for sure that that's a single replacement because it can't be double replacement because what would you be replacing it with? And then uh, if there's two compounds, then you and then they switch, then you know that it is a double replacement. hmm But then also, double replacements, when they switch, many times they could create some sort of precipitate, such as a gas liquid or a solid, and that can be easily seen when you combine the two. But with single replacement, you can also see sometimes that it produces a gas, such as hydrogen gas or oxygen gas, and but many times it does not produce a solid in the way that a double replacement does, because it has like usually like a vicious, I guess you could say, transition. Because if you look at it, there's one element and it's trying to kick out another element, like boom, out of the way, so that it can become switched and then become AC plus B. But with the double replacement, you can look at it all as separate. So A plus B plus C plus D, and then that becomes something like AD plus C plus B, or like, because some of them still remain inside the the solution as a liquid, and many times the reaction isn't as fierce as it would be in a single replacement because it's not really kicking anything out, it's just mixing together and producing like a solid or a gas or something like that, and that's another way to easily distinguish them. And yeah, hope you enjoyed, and thanks for watching. Bye. Woo.